Everyone, this is Modula and Podrick, and we will be informing you all about what is going on in the digital world.
Welcome to the future, humans. Let's start.
You know, when we think about AI, we usually picture something that just lives in the cloud, right? It feels kind of weightless, digital, almost magical. But the truth is, behind every single chatbot response, behind every generated image, there's a massive physical world of steel, concrete, and an almost unbelievable hunger for power. Today, we're going to uncover that hidden world, and it all starts with a really bizarre mystery. So let's just dive right in with a question, a truly weird one that honestly reveals everything about the massive shift that's happening right now. Why on earth would a company, in this case Meta, spend a fortune building a brand new facility only to immediately bulldoze it to the ground? The story starts in 2021 with just an empty field in Temple, Texas. Fast forward a year, and it's this giant construction site for a huge new data center. But then, just a few months later, it's back to being an empty lot. Everything they built was just gone. It makes absolutely no sense. And we're not talking about a small change of plans here. This decision is estimated to have cost around $70 million. Just poof, vaporized. So, to understand why they do this, we first need to get a handle on what these buildings were supposed to be in the first place. Okay, so let's quickly talk about the old world, the traditional data centers that have been powering our internet for the last couple of decades. The easiest way to think of them is like the factories of the internet. Their entire job, their whole reason for being, is to host and send data to you, the user, as fast as humanly possible. So when you stream a movie or hop on a video call, the only things that matter are low latency and high bandwidth. That data has to get from their server to your screen with zero delay. And because of that, for these traditional data centers, it's all about one thing: location, location, location. You have to be as physically close to big cities and major network hubs as you possibly can. It's why a tiny place like Ashburn, Virginia is just jam-packed with them. It's the perfect spot to serve the whole East Coast. For them, being close to users is everything. But the facilities being built for AI today, they are a completely different animal, and I mean that. This isn't just an evolution. It's a total revolution in design, purpose, and, most importantly, power. In fact, calling it an AI data center is actually kind of misleading. A much better name is an AI supercomputer. See, its main job isn't sending you data. It's for training these gigantic AI models and then running what's called inference. That's the process of actually using the model to, generate an answer or an image. This is a whole different ballgame from just streaming Netflix. And this right here brings us to the fundamental difference, the big takeaway. A traditional data center's #1 goal is being close to users for low latency. But an AI supercomputer, its #1 goal is being close to absolutely gargantuan amounts of power, all for raw computational density. And this is what compute density looks like in the real world. A standard server rack in a normal data center, it might pull about 7 kilowatts of power. A brand new AI rack from NVIDIA, 132 kilowatts. The scale of that jump is just staggering. That is nearly 20 times the power packed into the same amount of space. We are not talking about a small incremental improvement here. This is a night and day difference. It's a complete reimagining of what a server rack even is. So, as you can probably guess, when you cram that much energy into such a small space, you create an incredible amount of heat. And the old way of doing things, basically just blowing a ton of cold air over the servers, is suddenly completely obsolete. It just can't keep up anymore. And this is exactly why the entire industry is pivoting hard to liquid cooling. For one, it's way more compact than giant air cooling systems, which lets you pack in even more hardware. Two, its performance is just on another planet. Liquid can absorb 4,000 times more energy than air can. And three, it's just way more efficient, which saves a fortune in energy costs when you're running hundreds of thousands of these chips. Okay, so now that we know all of that, we can finally go back to that empty field in Texas and solve our $70 million mystery. All right, let's look at that timeline again, but this time with one crucial new event added to it. Meta starts building in mid-2022. Then, in November 2022, OpenAI launches ChatGPT, and the entire tech world collectively panics. Suddenly, the AI race is on. By early 2023, Meta looks at the AI-capable facility they're building and realizes it's already obsolete. So they tear it all down to start over from scratch. And here's the proof. Just look at the before and after. The original plan was for 60 megawatts of total power using old-school air cooling. The new plan? 170 megawatts, built from the ground up specifically for liquid cooling. To stay in the game, to have any chance of competing in the AI race, they had to nearly triple their power budget and completely change the architecture. That $70 million demolition, that was just the price of not falling behind. But the story in Temple, it isn't some isolated incident. It's actually a preview of a much larger story, a global, high-stakes scramble for one thing, and one thing only: power. And the examples of this are just jaw-dropping. You've got Microsoft helping restart the 3 Mile Island nuclear reactor just to power its data centers. Amazon is building a massive facility right next door to another nuclear plant. Tech companies are now literally buying their own gas-fired power plants. Think about that. They're not just tech companies anymore. They're becoming energy companies. So how big is this new demand? Well, since the launch of ChatGPT, the new power required for AI compute is estimated to be somewhere between 40 and 50 gigawatts. And to put that number into perspective for you, 50 gigawatts is about the same amount of power that the entire country of France uses on average. That is the scale of new demand that's been created in just a couple of years. It's wild. Which leads us to this pretty stark prediction. This race for AI supremacy is creating a hunger for electricity so vast that it is on a direct path to become the single largest consumer of energy on the entire planet. The invisible digital world of AI is powered by a very real, very physical, and very, very hungry infrastructure. The race for artificial intelligence has now quite literally become a race for power. And that leaves us with one final and pretty sobering question. What happens when they inevitably need even more?